Hey, it's Mrs. Cat back again with another three levels diagram. This time we're going to be looking at solubility as a way to wrap up our objective of 8.1 on solution properties. Solubility is the maximum amount of solute that dissolves in a given amount of solvent at a specific temperature. We're going to look at this in all three levels, and we're going to start with our macroscopic level. So I'm actually going to split my macroscopic box in two, and we're going to look at this in a couple of different ways. I want to start out by defining soluble versus insoluble, okay, as two terms that we can look at macroscopically. When something is soluble, the solute will dissolve. In the solvent. Okay, versus when something is insoluble, the solute does not dissolve or will not. Okay, so I'm going to draw a couple of macroscopic pictures for what this would look like when something is soluble versus when something is insoluble. So we're going to draw a little beaker here, and we're going to draw our liquid line. When we were to put a solid in, or some sort of solute, okay, it's going to dissolve. And so it's going to look, your new solution that is formed is going to look homogeneous. It's going to be one phase. You're not going to really be able to tell any kind of difference in the solute to the solvent. Versus when something is insoluble, okay, if we have our, let's say we have, a liquid solvent, and we put in a solid solute, that solute would not dissolve. And in the case of a solid, it's probably going to sink to the bottom based on its density. Okay, so that's soluble versus insoluble. We also want to talk about saturated versus unsaturated. And when we look at these at the macroscopic level, we really can actually deal with this in the lab. So we're going to say if we're given an unknown solution, and we add more solute, one of two things is going to happen. Okay. So one, it dissolves. If this is the case, then the solution is unsaturated, which means the solution you started with can still dissolve more solute. Okay, so what we're going to wind up with a macroscopic representation of this is going to be what our soluble macro picture looks like. We're going to see that one phase, our homogeneous solution. Okay, our other option is if we add more solute and it does not dissolve, then the solution that you started with is saturated. Now, here's the catch. You can't actually tell by looking at a solution if it's saturated or unsaturated, which is why we have to do one of these tests, because you could start with a solution and add more solute, and it dissolves to a point of saturation, and it's still not going to look like anything that's different. Or we could add more solute to a solution that is already saturated, and maybe we're going to wind up with a puddle of solute or a pile of solute at the bottom. Okay, so I'm going to relabel these. Let me do a slightly different color here. Okay, this is again unsaturated. Okay, both of these pictures here are going to represent a macroscopic version of a saturated solution. Okay, let's take a look at these at the particulate level. And we'll, in this box, we'll go ahead and define saturated and unsaturated, starting with unsaturated. So here, we're going to say more solute can dissolve. Okay, and I'm going to draw my nice little beaker. We're going to draw a liquid solute, or solvent, excuse me. Here's our liquid level. And then let's say, I'm just going to use this ratio here. We're going to say that we have 4 particles dissolved and 0 undissolved. Okay, so that's going to represent our unsaturated solution. Our saturated solution is going to mean that we cannot dissolve any more solute. So no more solute can dissolve. And then we're going to look at this again with 2 different particulate pictures. So I'm going to draw 2 beakers. I'm going to try to make them about the same size. Okay, liquid solvent in there. And then we're going to draw in our particle diagram. This time I'm going to go with, let's say my saturation point is 8 particles. So 4, 5, 6, 7, 8. So I'm going to say in this one, I have 8 particles dissolved and 0 undissolved. Okay. Now, because my saturation point is 8, I know I can't dissolve any more than 8 particles. So if I add, let's say, 12 total particles in my second beaker, I know that I can only dissolve 8 of them. So there's 3, 4, 5, 6, 7, 8. And let's say those remaining 4 I'm going to put together as undissolved. Okay, so let's kind of circle these, point those out. Okay, we still have 8 dissolved. And then we have 4 undissolved. Okay, great. There's 2 of our 3 levels. Let's take a look at symbolic. Now, a symbolic representation of solubility can happen a couple of different ways. We can see a proportion where we would say the grams of solute that dissolve per 100 grams of water. Okay, so that's our proportional representation of solubility. Okay, we can also see this graphically. So let's see here. There's my X and my Y axis. This is going to be grams of solute dissolved versus grams of solute added. Okay, and what we're going to see on a solubility graph like this of solute dissolved versus solute added is we should see an increase in the amount of solute that dissolves up to a certain point, and then we're going to see that plateau off. Okay, so I'm going to highlight this with 2 different colors. And we should be able to recognize on the graph that in this point when we can still have solute that can be added and dissolved, this is going to be where your solution is unsaturated. Once the amount of solute added can no longer be dissolved and that plateaus off, in this region here, that's when our solution has reached saturation. So at this point, our solution is saturated. Okay. One final symbolic way that we can look at solubility is with a solubility curve, which we're going to define real quick. You've seen these in the models as well as on worksheet number 1. This is going to show solubility at many temperatures. Whoops, we don't want to show, we want to show solubility. Many different temperatures. Okay, they often show more than one substance as well. Okay, whereas this graph that I've drawn so far, that's just going to be one substance at one specific temperature. So a solubility curve, our axes are going to be solubility and temperature. Makes sense, right? And remember, this is grams solute per 100 grams of water. Okay, that's what we measure solubility in. And then this is going to be in temperature, typically in degrees Celsius, though we can use Kelvin. Okay, and we're going to see two main types of solutes on these solubility curves. One where we're seeing an increase in solubility, and typically we see these with ionic solids, like sodium chloride, potassium chloride, sodium nitrate, things like that. Okay, we also see some that curve downwards where solubility is going to decrease with temperature, and we're going to see that when our solute is a gas. Okay? And we can use both the solubility curves and the graph of solubility to look at some information about our solutions. So between this 3 levels on solubility and the one on solvation, that's going to cover everything that you need to know for Objective 8.1 on solution properties. Please make sure that if you have any questions to reach out to your chemistry teacher, and we will be glad to help you. Have a great rest of your day.